Hello, good afternoon. Right now, there's only one person in the class. Can you hear me? Hopefully, more people will join real soon. Okay, yeah, people are starting to come in now. Okay, do you see the desktop? Can you hear me? Does everything seem okay?
Yes, sir.
Okay, great, thanks. There's still only about half the people are in so far, so give it another minute for people to come in. Okay. We're gonna pick up where we left off last week, or on Monday. We're going to continue looking at events. Okay, we're going to continue looking at examples of event-driven GUI programs. Okay, so first of all, on Monday we start meeting on campus. Okay, so the university sent out an email to, I think, to everyone, letting them know that on Monday we go back to normal meeting on campus. When we meet on campus, there won't be a Zoom component to the class. In the classrooms, there's no way for me to create a Zoom meeting in the classroom. So there won't be video recordings of the classes once classes start on campus. Okay, so that part of the class won't be available anymore. So on Monday, I don't remember what room we're in. I have to go back and look what room we're scheduled to meet in. I forgot what it is now. So, but on Monday we'll meet in the classroom. Okay. And then you have a homework assignment. Does anybody have any question about the homework assignment? That's what we talked about it a little bit on Monday, but now you had a chance to look at it. Does anybody have any question? Did they want to ask about the homework assignment so far? Anything come up? Any questions about the homework assignment? Anything at all? Okay. Okay. So, okay. If there's no question about the homework, we're going to start looking at these event examples. This homework assignment you're doing, this one, that the current one is all about just drawing. Okay, this is just a drawing assignment. You have to draw, you have to paint these pixels. Once you paint them, everything stays put. Okay, there's nothing interactive in this example. Your next homework assignment is going to start using what we're going to talk about today and Monday. You're going to make a version of this program interactive and have it be able to do something. Okay, so let's download this zip file on the events. Okay, now in class the other day, we looked at this example that lets us watch events. Okay, so this program here this program here just lets us watch events as they happen. Okay, so this thing controls what we can see. This is where the events come from, and this is where the results go. So for example, turn on action events and the button generates action events. Okay, and we can watch the action event over here. Okay, and there's 1, 2, 3, 4, 5 kinds of GUI components over here. There's a lot more than 5 kinds of GUI components, but these are like the most basic: a button, a drop-down list, a checkbox, a scroll bar, and a text area. So 5 kinds of GUI components. And if each kind of GUI component produces its own kind of events. So text events don't come from the button. See, if I click the button, I don't get text events. I get text events if I click in here. On the other hand, the text area doesn't give me action events. I don't get action events from this guy. I said, oh, this action event is when I hit the enter key. What's interesting is in a text box, if you type text, you don't get anything, but the enter key special. The enter key, essentially, the enter key is usually when you're told this is the final result of a text box. So the enter key creates an action event. Notice that this is how, that's the usefulness of this program here. If I turn off the action events and turn on the text events, I can see that I'm getting text events. But if I hit enter, I don't see anything happen because the enter key does not create a text event. The enter key creates an action event. So if I turn on both of them, if I'm typing, I see the, let me clear this so you can start. As I'm typing into this text box, I see text events. And then if I hit enter, I get an action event. Okay. Now, what about item events? Does the text box, let's turn off that and turn off that. Turn on item event. Does the text box generate item events? Backspacing doesn't do anything. Typing doesn't. Entered. So the text box doesn't create item events, but it does create text events, and the enter key creates an action event. Okay, so this is a program that lets you watch events to see how they happen. Now, if you read the documentation real carefully, it tells you all this stuff, but at the same time, it's interesting to just play around and see it happen, and see that the text area. Oh, let's see. The text area. Oh, I'm sorry. I put the wrong. The text area. Okay. Now let's see. If I type a bunch of letters. Okay. What if I highlight them? Notice that, see, this is not creating text events and not, okay, I'm highlighting them. I'm gonna hit the backspace key. Hitting the backspace key did generate a text event, okay? But notice that moving the arrow like this does not generate any text events. Now, there are some kind of events being generated here because the program's responding to my keystrokes, but those aren't text events. Okay, and they're not action events either. I'm not sure what those are, but they're not action events and they're not a text events. If I type, I get text events. Hit the backspace key, that's a text event. But if I use this arrow key, the arrow key does not create any events. See? Typing creates events, but the arrow key, nothing. Okay. Now, I'm not really even sure myself what kind of events the arrow key is generating. It must be generating some kind of event because this program is responding to my arrow keys, but they're not showing up in this program. Whatever event these arrow keys generate don't show up. The left and right arrows move it back and forth. The up and down arrows don't do anything right now. Okay, so this program lets us see events. Now, this folder here is similar to the program we were just looking at. This program bundles everything together. It lets you see all kinds of events taking place. This program just bundles all kinds of events into a GUI so you can watch them. What this program does is it writes a bunch of simple little programs, one for each kind of event. Okay, so like this program just lets you watch only action events. Okay, if I open that program, okay, it's a simple program that's going to just create a single combo box. I'll just compile it and run it. Okay. Where's the combo box? Oh, there's the combo box. It was kind of hidden, didn't show up. The program didn't come up properly, so the combo box got hidden. And you can just see each time I do something with the combo box, I get an event. So this program just shows you one component and one kind of event from it. Okay. Okay. So I'm getting action events. So I'm getting action events from the combo box. If I okay, every time I select it, notice I don't get any event from doing this. I get an event when I pick something in there. Okay, so that just shows you one simple kind of event, and all it's doing is creates a frame, so it gives it a layout, gives it a size, makes it visible, creates a combo box object, gives the combo box 3 entries in it, then it gives the combo box a listener that handles the events from the combo box, and then it adds the combo box to the panel. Okay, so it makes the combo box visible. And then this is what we're going to talk about more today. This is the thing that handles the events. And that's the part that's going to be tricky. We want to see what's the connection between this combo box. This is the combo box object. This is the listener for the combo box. Okay. The combo box object is written by Java. I write this listener. This line of code puts the combo box, makes it visible. This line of code says that this is the handler for the events from this combo box. Okay. So, so it's a kind of a complicated little bundle of code. This creates the combo box. This makes it visible. This creates the listener, which I wrote here. And this line of code ties the listener object here to the combo box object here and says that when an event comes from here, it should be handled over here. That's what we're going to be mostly talking about today, is this event handling behavior here. What's really going on there? Okay. Now, another example here would be a mouse event. Okay. So here's a program that just a real simple example of a mouse event. Okay. Compile it, run it. Okay. And see, if I just move the mouse over here, I get, oh, the mouse entered my area, the mouse left my area, the mouse entered my area. I click down on the mouse, I release the mouse, click down. I'm dragging the mouse, but this is not the right kind of event handler. This doesn't do mouse dragging events. This thing only does mouse leave, mouse enter, mouse down, mouse up. Okay. So those are one kind of mouse event. That is what's in Java lingo, that's called a mouse listener. It handles mouse clicked, mouse entered, mouse exited, mouse pressed, and mouse released. Notice it doesn't do anything with mouse moving. That's handled by something else, this mouse motion guy. This mouse motion guy handles mouse dragged and mouse moved. So now this program, if I compile it and run it, okay, now I have a place to do mousing in. Now notice that it doesn't respond to mouse in and out, but it responds to any kind of motion of the mouse, which is a lot of events. Because every time you move the mouse, every pixel it moves, it generates an event. Now that's just the mouse moving. Now if I mouse down, now if I press the mouse down, this thing didn't notice that. I release the mouse, this thing doesn't notice it. If you have this at home, you should run these programs yourself and see that if I press down on the mouse, nothing happens. But if I drag the mouse now, see, I get mouse dragged events. So I'm moving the mouse with the mouse button down. Now I release the mouse button. This program doesn't notice that, but now I move the mouse with it up. If you want to know when, you can combine these two programs. This one knows about mouse movement. This one knows about mouse down, up, down, up. Now, some programs only want to know about mouse down and up. Some programs want to know about mouse moving. Some programs want to know both. And so then they have to combine the mouse listener with the they have to combine the mouse motion listener with the mouse listener. Notice that those are, from the point of view of Java, that's two separate ideas. The mouse listener just checks for these things. The mouse motion checks for these two things. Notice that they all take a mouse event. See? Notice that the way Java does it is that the kind of event is not really determined so much by the object as by what method gets called. So all of these take a mouse event, and both of these take a mouse event. So the mouse event object is used for what amounts to 1, 2, 3, 4, 5, 6, 7 different kinds of events. It's the function that really tells you what's going on. Okay, so a mouse event has a lot of information in it, enough information to satisfy all 7 of these methods. But the way that Java distinguishes between whether you're dragging the mouse with the button down or dragging the mouse with the button up is these two functions. Other systems do it differently. You can design a GUI system where there's just one mouse method, but it's overloaded to take 7 different kinds of mouse event objects. See here, they have one mouse event object and 7 different methods that take those mouse event objects. The orthogonal way to do this is to have one mouse method, but overload it to take, like, that it would look something like this. Somebody else could design a system where instead of having, I have a broken keyboard. There's 5 methods, and there's 2 more methods. Okay. Now, what Java does is there's 5 different names of methods. Okay, but they all take the same mouse event. See, they all take the same type of object. What you could do is you could move this you could move these, this part of, change the name. So mouse method on a mouse clicked event, a mouse method on a mouse entered event. Now, somebody could design the system this way. There's one mouse method, but it's overloaded to take 7 different kinds of objects. I don't know if some GUI systems work this way, some GUI systems work the way Java does it. Okay, I think the way Java does is probably the better way, but you can argue about which of these are better. Should you have one method that's overloaded with all these different event types, or should you have one event type and overload it with all kinds of different methods? Okay. So this would be the orthogonal idea. Do you hear me?
Yes, we can.
Yeah, we can hear you.
Yeah. What do you see? Because Zoom is doing all kinds of strange things on my desktop.
We see nothing at the moment.
Pardon me?
We don't see anything currently.
Yeah, I lost. Okay, I'm going to turn screen sharing back on. Do you see the desktop now?
Yes. we do.
Yes.
Okay, I think my internet connection's getting flaky. So I think Zoom temporarily stopped. I think my internet connection went out. Okay, so yeah, so here's 2 orthogonal ways to design GUI system. One way, Java way is one kind of event, but all different kinds of methods. And then the methods are actually grouped under different listeners. So these two methods are under this listener, and these 5 methods are under mouse listener. Okay, so it's kind of it's a design choice, and you can quibble about that design choice. The other possible design choice would have been to have one method, but then have lots of different events that could be passed to that method. Then this method could check the type of that event. And these would be overloaded. You'd actually still have 7 different methods. They're just overloaded to take different kinds of types. So this would be 7 overloaded methods. Okay. Okay. Part of learning computer science is to learn about different design patterns. So this is a good example of how you can choose different design patterns. You need somehow to distinguish between all these different mousing things. You need to be able to distinguish between mouse button down, mouse entering the window, mouse exiting the window, mouse button up. You need to know when the mouse is being dragged with the button down, when the mouse is being dragged with the button up. So there's all these different things you want to know about. Java did it with different methods, but one object type. Now, they could have even had different methods and different type. They could have had a different type for each one of these different methods. That probably would be overkill. But they could have had each one of these methods had its own type for that method. But they have one mouse event type for all these methods. They have 5 of the methods grouped under one group, the mouse listener group, the mouse listener interface. And they have 2 of the methods in another interface. Okay. Why they divided them up into 2 interfaces, I really can't say. I don't know. Why didn't they just put all 7 of those methods under one interface? Why did they break it up into 2 different interfaces? Probably after they looked at thousands of lines of code or millions of lines of code written by different people, they might have decided that people tended to either use these 2 methods together, or they tended to use these methods together. They probably noticed that there was some pattern to the way people used it, and they just thought this would be more convenient. It doesn't really change what kind of code you can write. If they had put all 7 of these methods in one interface, it wouldn't change anything about what you could write, but maybe this way makes it a little bit easier to write. Similarly, if they did it this way, that wouldn't change anything about what you could write, but maybe it would make, maybe the code wouldn't be quite as elegant, or something would be different. But so they chose to do it this way. Okay. So in this folder, there's all these different action event, adjustment event, component event. This is an action event that comes from a timer, so it's a little bit different than this is an action event coming from a combo list. This is an action event coming from a timer. Adjustments, scroll bars. This is a low-level event, something called a component event. That's the event you get when you do things like minimizing and maximizing a window. Those are component events, minimizing a window and maximizing the windows. Okay. And same with the component and window events are low-level events having to do with a whole window. Okay. Okay. Now, what we want to do now is switch, instead of talking about all the different kinds of events, let's switch direction to looking at how you handle an event. How does Java actually, what are the specifics of what do you do when an event happens? Okay, so this folder here talks about all the different kinds of events, but doesn't say, it only does this one way of handling the events. All the events are handled the same way. They just print out themselves. This folder here, this folder here goes in the other direction. Every example in this program, in this folder, is doing the same thing. It's drawing a little program that handles key events, but it's handling the key events in about 12 different ways. There's a huge number of different ways to handle key events. So the name of the folder is how to handle handlers. So essentially it's two orthogonal ideas. What kind of events you can have and how do you handle the events? Okay. This is the harder part. The harder part is how to all the different ways of handling events. That's actually the harder part. What we're gonna do is see this folder here. This is the most simple example. We're gonna look at this example here and look at a real simple example of handling an event and get the basic idea of what Java does to handle an event. Okay, so first of all, let's run the program. The program's been broken up into 4 files because we'll see there's actually 4 different responsibilities going on in this. Okay, so this is the actual program. If I compile this program, it actually compiles all these files because all these files together make up the program. Okay, and what the program does, it's a simple little program. If you run it, that red dot responds to the arrow keys. So the up arrow key makes the red dot go up. The right arrow key makes the dot go right. The down arrow key makes the dot go down. And the left arrow key makes the dot go left. Okay, so you can move the dot around, kind of like an Etch-a-Sketch toy. Okay, so it's just respond. No, it doesn't respond to anything else. It doesn't respond to mouse. See, I can't click on this. It doesn't respond to mouse clicks. Doesn't respond to any other key actions. It's only responding to one kind of event, the 4 arrow keys. Okay, and so it only responds to one thing. But what we're going to do is we're going to end up writing this program 12 different ways and see all the different ways that you can handle this one kind of event of the 4 arrow keys. Okay. Now, here's a document that gives a kind of an outline of what's going on here. This is people draw diagrams to describe object-oriented programming. Like here's a link down here to another website of somebody who's trying to document similar idea. And if you look through here, here's pictures of a GUI. Okay, that's a picture of a GUI. Here's a picture of class inheritances. Okay, now further down, you get to more interesting pictures that are trying to show class relationships. These are pictures that try to show how classes are related to each other. Here's another example. That's what we're going to try to understand right now. How are classes related to each other? Okay, so he's using a certain kind of diagram in here. Well, you see these diagrams all over the internet. This is a certain style of diagramming, and this is kind of a simplified version of that style of diagramming. Okay, so this program has got 1, 2, 3, 4, 5 kind of objects that are talking to each other. Now, I wrote 1, 2, 3, 4 of those objects, and those are the 4 files in this folder. The 1, 2, 3, 4 files in this folder correspond to these 1, 2, 3, 4. This object here is created by the Java virtual machine. Those are the event objects. We'll say what they are in a minute. I don't write those. We don't write these. They come with the Java virtual machine, but we write these things. Okay. Well, actually, we don't write all of them, but we're responsible for defining certain aspects of them. Okay. We will instantiate this object, this object, this object, and this object. We won't instantiate this object. This object will be instantiated by the Java virtual machine. So we won't create that object, but our code will create this object, this object, this object, and this object. Okay, here's what it is. This is a GUI object that is the source of events. Over here, that's this panel here. This panel is the thing that senses that the key is struck. Okay, so this frame, actually it's the frame. This frame is in our picture over here. Oops. This is the frame. Okay, it's the source of the GUI events. Okay, now when I hit the arrow key, every time I hit the arrow key, the Java virtual machine creates an event object describing what just happened. Okay, so now this is the Java virtual machine, see, created by the Java virtual machine. Over here, every time I hit a key, an event is created. And that event object is delivered to whoever I instantiated as the event listener object. So I designated some object as the responsible agent for handling these key events. Okay, so over here, every time I hit the up arrow key or the down arrow key or the left arrow key, an event gets created and delivered to this event listener object. Now in my code, I have this circle listener program. The circle listener is the event listener. And it gets compiled to the circle listener class, then it's going to get instantiated to an event listener object. Okay, that's this code here. It is the listener. Okay, so the Java virtual machine will deliver this object to this guy. What this guy will do is he'll look at the object and decide what it means. Is it the key going up? Is it the key going left? Is it the key going right? Is the key going down? And what this object will do is update this data object. This is going to be a data object. This is where my program remembers where the dot is. This object here will record where this dot is on the screen. When this object finds out that the arrow key, up arrow key is hit, then it'll tell this object to record the dot has moved up. Now, this does not draw the dot. That's going to be somebody else. This is just a state object. It records the information about the dot. So its responsibility is to just store information. It's a data object. So when this handler gets an up arrow key, it tells this thing that the dot has moved up. If this thing gets sees a down arrow key, it tells this thing that the dot has moved left or down. Okay. Now, after this guy has recorded that information, then this guy sends a message to the GUI object that does the painting and tells the GUI object that the state information has been updated. Okay. So the event comes in, the event is delivered to the handler uses the event to update the data, then the handler tells this guy to, oh, it's time to redraw yourself because something has changed. Okay. This guy then reads the data object to find out what's changed and repaints the screen. Okay, so here's the 4 files. Okay. Okay. See, I'm gonna write the code that creates the GUI object that starts the events. That's this frame. So I'm gonna write something that draws this frame. I'm gonna write something that decides what to do when the arrow keys are struck. That will be this circle listener program. Okay, we'll look at exactly what it does in a second. Okay, then I'm gonna write a program, a file that keeps track of the information I need to know. That's this state. Now, all it holds is 4 ints. Okay, so it holds 4 integers that are the x and y coordinate of where the dot was, well, where the dot is and where the dot needs to be. So the x old and xy actually are where the dot is. Then if somebody hits the key, that's specifying where the dot needs to move to. So this is going to hold where the dot should be after the key is pressed. So if the up arrow key is pressed, then the y coordinate will change. If a left or right arrow is pressed, then the x coordinate will change. Okay. So these 2 variables store where the dot currently is. These 2 variables store where the dot needs to move to. So it's just 4 ints. Okay. That represents this object here. This thing will update that object. When I strike the up arrow key, the up arrow key will change y new, because y is the vertical coordinate. So the up arrow key will actually, remember, Y is measured going down. So the up arrow key will subtract from Y new. The down key will increase Y new. The left arrow key will decrease X new, and the right arrow key will increase. Okay, so over here, if you run the program, you can try it for yourself. Up arrow key moves the dot up, but that's decreasing the Y values because Y equals 0 is up here. Okay, and the down arrow key over here, the down arrow key will be increasing Y values. The left arrow key will be decreasing the X new value. Okay, so in this picture here, this event handler, it looks at the event object and finds out if it's a left arrow key, right arrow key, up arrow key, or down arrow key. So the event handler looks at the object, sees what kind of key it is, and then it updates the data over here appropriately. After it's updated this data, this guy then says it's time to repaint this picture. Then the paint thing is this circle panel. It's the one that knows how to paint. See, there's the paint method. What it'll do is it'll draw a white circle where the dot currently is, then draw a red circle where the dot should move to. So it'll erase the old dot. See, it'll erase the old disk by drawing a white dot where the disk used to be. Then it'll draw a red dot where it should be. So it uses the old value of X and Y. Now, see, this is looking up X old and XY in this data object. So this guy's got to have a reference to that data object. If we go back to this picture, all these objects need to know where each other are. And that's one of the things that we're going to, that's one of the things that makes this stuff tricky, is there's all these objects. And right now, this picture doesn't show it, but these objects need arrows or references to each other. So for example, the event handler needs a reference to the data object and to the paint object. The paint object needs a reference to the data object. The data object doesn't need a reference to anybody because it just stores information. But this object needs a reference to both of these two objects, and this object needs a reference to this object. Okay, so that kind of stuff will have to be set up somehow. And that's where there's lots of different ways of doing this. How these objects communicate with each other is the tricky part. This just sketches the idea that there's these 4 responsibilities: the source of the events, the event handler, the state data, and the program that repaints the component. Those are the 4 responsibilities. These responsibilities need to know how to communicate with each other. The communicating part's the tricky part. Okay. Now, okay, so let's go back. Let's go look at it again. The circle program starts things off by building this frame. See, there's where it builds the frame. Okay. Then it creates an instance of the object. This is creating the data object. Okay. So the program creates this frame, then it creates a data object, then it creates the panel that is going to sit in this frame that does the drawing, and it tells the panel, here's where you get the data you need. See, that's passed as a constructor. It's passed as a reference through the constructor. So the circle panel will know how to find the state information. Okay, so in this picture, that's this guy needs a pointer back to the data. This guy needs to know where the data is, and that'll be done through a constructor. When the circle panel, the thing that draws, is created, it'll be passed a reference to the circles, the data. Now the data doesn't need to know anything. The data doesn't need to know where anybody else is. This object does not need to know where any of the other objects are. Everybody needs to read and write to this object, but this object doesn't send any messages out to anybody. It just receives information. It lets people read it and write it. That's all. Okay. So the program creates the circle state object, and then it creates the panel object and says, here's where the circle state is. Then the panel object is added to the frame. So it'll show up in this part of here of the frame. So the panel will show up here as part of the frame. Okay, so that's this thing here. Then you pack the frame, set its location in the window so that when the program starts up, this will be at the center of the window. Then you make it visible. Okay, right? Then this creates the listener object. This creates the thing that handles the events. Now remember, this guy needs to know where the data is, and this guy needs to know how to tell the paint component it's time to repaint. So this guy needs access to both of these two objects. So over here, when you call the circle listener constructor, it's passed the state information and the drawing panel. Okay. Now, this program, after it builds all this stuff, goes away. Okay. This program stops running. Actually, I shouldn't say the program stops running. The main thread, the constructor stops running, and this program just doesn't do anything anymore. Okay. After that, this is kind of a tricky part of this. Who's in control of all these objects? Who's calling this method? Who's calling this method? It's not my program. I'm never going to call this method, and I'm never going to call this method. If you look at all this code here, you'll never see anything I wrote calling paint component. Okay. And you'll never see anything calling this Keypress method. Okay. Okay. The Keypress method is the method that you're going to call, and that's this handle event. In our case, the handle event is going to be Keypress. Okay. That's the event handler method. I'm not going to call that method in my code, and I'm not going to call that method in my code. What we're seeing now is this idea of what's referred to in computer science as inversion of control. Okay. It's the general idea is inversion of control. What are they? If you invert something, you're turning it upside down. Invert is a fancy word for saying turning something upside down. What do they mean by inversion of control? Okay. In normal programming, what they mean by control is one function calls another function, and what it's doing is it's passing control of the program from one function to another function. So when function F calls function G, then the CPU moves from executing function F to executing function G. So control of the program is transferred from function F to function G. The way you write computer programs is you write a bunch of functions that call each other. Okay. A classic example of that would be, you want to do some manipulation on a string. So you create a string object, and then you call the toUpperCase method on the string. Then you might call the index of method. You call methods that do things. Your program's in control. Your program decides what function to call. It calls that function. Then the function returns to your program. Your program decides what other function to call. Your program calls. That's the way you write programs in CS1, introductory programming classes. In fact, that's the way most programming is done. The functions are under control of your program. Your program calls functions. Okay, now we're going to do inversion of control. We're going to invert the control. Now you're no longer in charge of who calls what function. Under inversion of control, you write a bunch of functions, and then you give them to somebody else, and they decide when to call them. They're in control. They decide when to call your functions. Instead of you writing functions and you calling your own functions, you write functions and let somebody else call them. That's the case of these two functions. Who's going to call them is the Java Gui Framework. Part of the idea of inversion of control is using the word framework. When you invert control, you're giving control to somebody else. Usually you give the control to a framework. Now that word is not a well-defined word, but quite often you turn the control over to a framework. kind of a weird distinction in computer science is framework versus library. Okay. So, notice I get the difference between a framework and a library. Okay, here's the idea. The string class in Java is a library. It's a small library, not actually too small. It's a library of functions that you can call. Here's a whole list of them. There's about I don't know, 50 functions in this. It's like a little library of functions. Okay, you call them. If you want to 2 uppercase a string or 2 lowercase a string, or search a string for a substring, or if you want to trim a string, or you call the methods. A library is the normal control. A library says, here's a bunch of functions that you can call. You get to decide whether you want to call them or not. You're in control. So a library is you call the functions. A framework is the inversion of a control. A framework, you write a bunch of functions. Okay, a library, somebody writes the functions and lets you call them. A framework is the inversion of that. You write a bunch of functions and somebody else calls them. In a framework, you write functions, but you never call them, somebody else does. In our case over here, we write this function and we write this function and we never end up calling them. This function is in this file here. It's this Keypress function. This function here is in this file here. It's this paint component. I don't write any code that calls those functions. They're going to be called by the Java virtual machine as part of the Gui framework. It's the Gui framework that's now in control. Once my main method exits, if you go back here, after I've set up the Gui and my constructor of my main method calls the constructor, and the constructor does its work and exits, my program continues running even though main is done, because now my program's under the control of the Gui framework. And the Gui framework is the framework that receives the event objects, sends the event object to the event listener. It calls my event listener. My event listener tells the framework it's going to time to call the paint component. I actually will not call this method. What I'm going to do is we'll see in a minute in the code, this method will inform the framework that it's time for the framework to call this method. Okay, that's done over here by this repaint method. Really quirky. See this repaint method? The repaint method says it's time to repaint. If you look in my code, you'll never find anything called repaint. Repaint is something that's part of the framework. And what repaint does is it tells the framework that it's time for the framework to call paint component. Now, the reason they do it that way is because the framework wants to decide in what order all these, if it's a complicated GUI, there might be a lot of things that need to be painted. It's up to the GUI framework to decide when things should be painted and in what order. So I don't say to my program doesn't, I don't have this guy call this guy and say it's time to repaint yourself. This method calls the repaint, it calls the repaint method, which actually just informs the framework that it's the framework should call the paint component method at some point. Okay, so I never call this method, I never call this method. The Java virtual machine calls this method when it gets an event. See, right now, nothing in my program is running. Well, the framework is running right now. If you ask, what is the CPU doing right now? The CPU is running the framework. It's not running any of my code that I wrote here yet. As soon as I tap the up arrow key once, then what happened is as soon as I tap the up arrow key once, my listener got called. My listener updated the state information and told the framework it's time to repaint something. The framework got the message that it's time to repaint something, and the framework called my paint component method. My paint component method redrew things. And then my program's back to just doing nothing. Yeah. An event came in, the framework called this guy. This guy informed the, oh, let me show you, let me do a quirky little experiment. Comment out one of these repaints. Now, when this event, okay, an event comes in, it's the key up event. You decrease the Y, but you forget to call repaint. Okay. And then if some other event comes in, like a key down, you'll call repaint. Okay. So let me recompile this. Okay. Now I'm going to run the program in this new version. Okay. Now here's moving the key right, down, left. Now I'm going to tap the up arrow key. Now I'm tapping the up arrow key, but nothing's happening. Okay. Now what's happened? I'm tapping the up arrow key. Right now, the GUI system is getting those up arrow events, passing them to the event handler. The event handler is processing the up arrow events, but forgetting, see, forgetting to tell the event, the framework, it's time to repaint. So there's no repaint events being sent. On the other hand, if I hit the left arrow key, the left arrow key will then call repaint. And then I'll see all my up arrows. Now here, I'm going to hit the left arrow key. What happened is all those up arrows that had been recorded in the state information but not been repainted, all of a sudden they got repainted with one move left. So this dot here was that dot there, moved left 5 pixels, but it jumped up. Okay. Then if I move right, see, and then I can do that same thing again. I can move right, I can move down, I can move left. Now I'm going to move up. Now I'm hitting the up arrow key. You should try this at home and see how it works. The up arrows are being recorded. Every time I do an up arrow, an event is being generated. The event's sent to the handler. The handler is handling the up arrow keys. It's updating the state information, but forgetting to send a repaint message to the framework. Okay. But then if I go over here and type a down arrow key or a right arrow key, when I hit the right arrow key, that updates the state information, calls repaint, and now repaint sees all those stored updates to the, it'll see all the changes that have been occurring to the Y new, and the dot will jump up. Okay. Notice that this stuff can be really tricky. In a general program, you know, when you're supposed to call these methods, you have to do this stuff real carefully. If you don't do this stuff just right, you can end up with programs with subtle errors in them. For example, in this program, I purposely put the repaints here, 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 and here, so I could do that experiment. But the right way to do this would be to put the repaint once down here. So what I really, the right way to write this program would be to just have repaint down there. So the key comes in, you record the state, and then after you figured out which state there was, then call repaint. That would make it more robust. But I purposely made the repaints, I put 4 repaints in there because I wanted to play around with them. So I purposely wrote it in a kind of a quirky way so that you could play around. But the right way would be process the key, then call repaint. Okay. But I'm gonna leave it the way it is, because this way you can play around with it. You can turn off and on those repaint signals. Yeah. Like if I do it this way, now the left arrow key doesn't notify on repaints. Okay. So I can compile. If I go back and run this program now it's going to be the left arrow key that doesn't work right. Okay. Up arrow key works fine. right arrow key works fine. Down arrow key works fine. Now the left arrow key, I'm typing left arrow, left arrow, left arrow, left arrow. Nothing's happening. If I hit the up arrow key, see the thing jumps over. All those left arrows, they were being recorded, they were being stored, but they were not notifying the framework that it was time to repaint. Okay. Now, here's another quirky thing. Why don't I just call repaint directly? Instead of me sending a message to the framework saying it's time to call repaint, why don't I call it directly? Okay, let's see if that will work. You're not supposed to do this, but what you're not supposed to do and what you physically can't do are two different things. So what I'm going to do is I'm going to change this from the control panel repaint to the control panel paint component. I'm going to go ahead and call paint component myself for the left arrow key. Okay, now that doesn't compile because, let's see. Oh, I have to be careful. It needs, see, it's hard to call this method directly because it needs to know what it's drawing on. Okay, so it needs to be told, repaint yourself here. Okay, I don't know if I can get, let's see if I can do that. Now, see, now here I forgot to say what to repaint. Okay, so what I'm repainting is the control panels dot get graphics. I think that'll work. Let's see. Yeah, see that compiled. So now I'm saying, go to the control panel, get its current graphic state, and repaint it. Now, you're not supposed to do this. I'm not sure exactly if this is even, now it did compile, but I'm not quite sure how it's going to behave. Okay, so on the left arrow key, I've done something quirky. Okay, so right arrow key is fine, up arrow key is fine, right arrow key is fine, down arrow key is fine. Now here's the left arrow. Oh, it seems to be working. Oh, but look, it's weird. See how smooth? Oh, real weird. Now I've got two red dots. Okay, see the up arrow key, see how smooth it is. The right arrow key, see how smooth it is. The down arrow key, see how smooth it is when I hold it down. Now the left arrow key, it's jittery and it's also flaky. See, when I switch from left arrow to right arrow, I got an extra weird dot there. See, I'm breaking the rules of the framework. When you break the rules of the framework, now this is really interesting because when you break the rules, the compiler should tell you. Java's not designed as well as it could be. Here I broke a rule, but the compiler didn't know that. I broke a rule, pretty big rule too. Really, I mean, I'm doing really the wrong thing here. I'm really doing something wrong here. Okay, but the compiler doesn't know that. And this is actually a very interesting design feature of programming languages. Can you possibly design a language that would know that this is not what you're supposed to do? How can the framework and the language work together? That's a very difficult modern research problem. Okay, so I'm doing something that the framework documentation tells me don't do this. You know, if you read the paint component method in the documentation, actually, let's see, we'll try to find it. The paint component method is in the J, I'm pretty sure it's in the J component class. Okay. It warns, actually, they tell you all kinds of warnings. You know, if you do not honor the opaque property, you will likely see visual artifacts. Yeah, and here they don't tell you not to call this method. In other places, they just flat out tell you, don't call this thing. Do not be calling this method. Here it doesn't quite say that, but it warns you that if you do call it, you better be really careful. It says you might get unexpected results. You might see visual artifacts. Yeah. So here it doesn't flat out tell you not to call it, but in other places in the documentation, it just says flat out, you shouldn't be calling this method. Okay. So I'm breaking a rule of the framework, but that rule of the framework, it's not like the compiler can't check it. The compiler can tell when you're calling the wrong method. The compiler can tell when you have the wrong parameters. The compiler can tell a lot of things, but this is a real interesting example of something that the compiler cannot tell. Compilers don't work well with frameworks. Now, compilers work well with libraries. Remember, we looked at this thing about how what's the difference between a framework and a library? One interesting thing is, like the string library, you can't call these methods incorrectly. The compiler won't let you. This guy returns an int. If you think it's returning a double, the compiler will tell you wrong. This thing takes an int parameter. If you give it a double parameter, the compiler will tell you you're wrong. It's hard to call these methods incorrectly. It's hard to use them incorrectly. Compilers are very good at detecting mistakes in a library. They're very bad at detecting mistakes in a framework. And that's what we have in our code here. We have not a library mistake, a framework mistake. We're abusing the rules of the framework. We're doing things wrong. Our program kind of works. You know, now you have to imagine a program that's tens of thousands of lines long that has a little mistake in it somewhere where it breaks the framework. And people are going, well, you know, every once in a while, like once a week when I run this program, it does something funny. And the program's tens of thousands or even hundreds of thousands of lines long, and no one knows how to figure out why it's doing something slightly flaky. And it's more than likely that somewhere in the program, somebody violated one of the rules of the framework. Okay, somewhere there's somebody violating a rule of the framework, but the compiler can't find it. How do you find these kinds of mistakes? Good luck. You know, that's why we have buggy software. That's why lots of GUIs do weird things. The frameworks are very much a part of GUIs. Most GUIs are referred to as Gui frameworks. So you use the idea of a framework a lot when you do GUI programming. But frameworks don't really work well with compilers. And no one's ever been able to solve this problem. As far as I know, there's no language and no framework that solves this problem completely. Whenever you use a framework, the most famous framework out there right now is Spring. The Spring framework is a huge framework for writing web apps. Okay? The Spring framework. It's notoriously complicated. It's very large. Okay, it's the framework that people use these days to write internet GUI, internet applications in Java. It's the framework that's most used for writing Java-based internet applications. And it's a framework, not a library. Okay, and you have to work with it real carefully because it's this inversion of control. If you Google the phrase inversion of control, you'll see a lot of references to Spring. Okay, see, what is inversion of control in Spring? See right there, inversion, because Spring is a framework. So frameworks invert stuff. You write a bunch of functions, but you don't call any of those functions. The framework's going to start calling them. But then the framework's got all kinds of rules about who can call what functions, and those rules are not enforced by the compiler. So I shouldn't be calling this get graphics, and I shouldn't be calling paint component. And it's really hard for me to figure out why this program behaves this way. Like if I thought real hard, I might be able to explain why this program now behaves in this kind of quirky way. Okay. See, there's something quirky. See, when I switched to up arrow, it did something quirky. but not always. There, yeah. So the program's flaky, but it isn't flaky all the time. It's flaky sometimes. If this was a program that was 100,000 lines long and had, like, think of Visual Studio, some program with a massive GUI the program is hundreds of thousands of lines long, and every once in a while you click on some unusual menu item and it doesn't quite work right. And nobody knows how to figure out what's wrong with it, because somewhere in the code base, there's something that's not quite right, and it's hard to find those. Okay. There are programs that try to, this cannot be done by a compiler, but there are programs called static analyzers that try to analyze your code to find out if you're breaking framework rules. They're not language rules, they're framework rules. And there are people who've built what are called static analyzers to try to solve some of these problems, but it's a notoriously difficult problem. Okay, so now, this is interesting stuff. You're seeing in a baby situation a very deep aspect of computer science as a whole. Spring Framework is really important. The Spring Framework is notoriously hard to work with it because it's a framework and it uses inversion of control. It's a framework using inversion of control. So the compiler no longer has a way of knowing exactly who's allowed to call who, and that's what can go wrong. You get mixed up and you call the wrong function at the wrong point, you could be goofing up the framework. Okay, so this one goofs up the framework. Okay, so it should have been, it should have been, remember, the right thing here was to call repaint. So I'm replacing the call to repaint with a direct call to paint component. What repaint does is it sends a message to now the framework's not in this picture. It's the Java virtual, the framework's the Java virtual machine. When this guy calls repaint, he's telling the Java virtual machine that it should, when it thinks it's appropriate, call repaint. Okay, so I'm calling paint component. Calling repaint tells the framework it's time to call paint component. If you call paint component yourself, things go wrong. Okay, and that's real subtle. Okay, now again, the flow of control in this program is the program starts up, the main method calls this constructor. Okay, the constructor builds the GUI. The constructor instantiates all these objects except for the event objects. So the constructor instantiates the frame, it instantiates the paint panel, it instantiates one copy of this data object, and instantiates a key event handler, and it wires them together. So this code is wiring those guys together. So it's telling the event listener where to find the data and where to find the panel. It's telling the framework that this is the event listener object. Okay, so it's informing the framework which is the proper event listener. It tells the paint panel where to find its data. Okay, so it's wiring everybody together. After it's wired everyone together, after it's created all these objects, it goes away. This method returns. As soon as that method returns, the main method returns. Normally, that would mean your program is done, but your program has launched a GUI framework. Actually, the GUI framework is launched by that guy right there. When you make the GUI component visible, you're actually at that point launching the part of the Java virtual machine that is the GUI framework. Okay, so that actually activates the GUI framework. Oh, comment that out, compile the program, run it, nothing happens. Okay, because I never made anything. Actually, I thought the program would die here because well, something else has launched the event. Yeah, something else. The program didn't die. So that means that it's still running. It's still running. So, oh, I called this guy here. Yeah, actually, this guy started the GUI framework. I'm sorry, this thing, the swing utilities invoke later, this thing launched the framework, okay? I'll do a little trick here. The main method now is just going to do, just call the main method calls the constructor. It doesn't call the constructor in the GUI framework. It calls the constructor directly. Okay, and I don't make anything visible. Program's still running. Now I'm not even sure why it's running, because I didn't launch it in the swing. So this didn't launch the GUI framework. This one's not launching the GUI framework. Maybe this one launched the GUI. Something's still launching the GUI framework. Yeah, something's launching the GUI framework. I thought it was only, I thought only this line of code or this line of code would launch the GUI framework, but something else is launching it. Maybe this set default, it might be this even. Yeah, there's various lines of code could launch the GUI framework. Once the GUI framework is launched, then my program will keep running because it's being run by the framework, not by my main method's not running the program. The framework is running the program. Okay, so in this case, there's a whole bunch of lines. It might even, let's see, I can just try one last thing. Now, see, the GUI framework is still running. So I'm not sure. One of these lines of code is launching the GUI framework. And so my program, now it's not visible. Since I commented out this, I don't see any GUI, but the GUI framework is running because my program, see, it's there. It's really running. It's just not doing anything. Okay. Okay, we'll play around when we get, okay, on Monday, we'll be back in class and we'll keep looking at this example and we'll play around with it some more. And what we're going to do then is start seeing how you could start juggling these around. Like you can combine some of these objects together. There doesn't have to be 4 objects. These things can be combined together. Actually, you can do this all in one object. But you could have one object have the responsibility of this object, this object, this object, and this object. So you can have one object that has all these responsibilities. By spreading them out like this, it makes it clearer what's going on, but you can double up these responsibilities. So you can have anywhere from 1 to 4 objects. Okay, so we'll look at some examples of doing things like that. We'll combine some of these objects together. Okay? And we'll see various ways to use these objects in using Java, like nested classes, inner classes, static classes. There's all kinds of programming techniques we can use to combine these objects together. And people do it. People make all kinds of use of complicated programming techniques when they're handling these kinds of objects. Okay, anybody got any question? Any question at all? We've run out of time.
No question.
Okay. If you can go to this website and you can look at this guy's, he's drawing pictures very, you can read what he has to say here. This is another way to draw, see these diagrams with these arrows? He's trying to show you how different aspects of the framework are calling and sending messages back and forth to other aspects of the framework. These are called UML diagrams. So this is sort of an industry standard way to try to draw this stuff. So you can read this and this is one way to talk about how do one way to talk about these ideas. This simple picture is just another way to talk about these ideas. So, but most people find it easier to draw pictures to somehow visualize these ideas. If you just look at the code, it's inscrutable. If you just looked at this code and tried to figure out what these things are all doing and how they're working together, It's really hard. It takes some kind of, almost everyone agrees it takes some kind of picture to make sense out of this GUI stuff. It makes sense of this framework stuff. When you're starting to work with frameworks under inversion of control, it really helps to start drawing pictures. Okay, all right. So if you have questions about the homework, you can send me emails, and we can have a Zoom meeting. You can either just send me an email, ask a question, or you can ask me to meet with you in a Zoom meeting. And then on Monday, we'll be back in the classroom. Okay. Any last question?
Nothing else, sir.
Okay. So I'll stop the sharing, and we'll meet again in class in a few days. Have a nice weekend. Bye-bye.
You too.